Good morning, everyone, and welcome to another day of Friendo Today. I'm your host, Friendo, and today we're going to be doing some toy problems. Just getting some more practice in. Alrighty, so where do we want to pick up? Back to the top interview questions and do some more of those. All right, we've done arrays, we've done strings, we've done linked lists. Still a little rusty on linked lists. We could practice those. Reverse linked list, merge two sorted lists, and linked list cycle. Let's try linked list cycle. This one is, you need the two-pointer rabbit and hare trick. Oh, hold on. I don't want the answer. I guess I've done this one previously. All right. Given head, the head of a linked list, determine if a linked list has a cycle in it. There's a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of the node that's... Internally, POS is used to denote the index of the node that tail's next pointer is connected to. Note that POS is not passed as a parameter. Return true if there's a cycle in the linked list, otherwise return false. So we return true if there's a cycle, false if there is no cycle. So the way you test this out is with the rabbit and the hare, and essentially, not the rabbit and the hare, the tortoise and the hare. Tortoise and the hare. Turtle and the hare. Because I don't know how to spell. Wait, tortoise is T-O-R-T-O-I-S-E. I guess it's not spelled tortoise. Anyway. You have one pointer that goes through slowly, one pointer that goes through quickly. If the pointer that goes through quickly reaches the end, you know there's no loop. But if there is a loop, the one that's going fast will eventually catch up to the one that's going slow, and if they ever end up being equal to each other, you know you've discovered a loop. Okay. While call it is cycle. Let is cycle equal false. Return is cycle. All right, I don't know if we actually need the turtle.next here. I don't think this is really doing anything. But let's keep it just to be careful. Okay. So if hare equals turtle, is cycle equals false equals true, break. Else turtle equals turtle.next. Hair equals hair.next.next. Well, I got that one correct. Oh, wait, we're setting them equal to each other right off the get-go. Let turtle if there's no head.next, return false. Let's go check it out so we can debug it. Oh, if there's no head.next. Duh. Maybe we need to keep these. There we go. Hell yeah. Boom. All right. Nice. That one went quite well. While hair.next and hair.next.next. Hell yeah. Okay, not bad. And then this should update with this information, right? Nice. All right. Let's get to work on some tree problems. Binary search tree. Bum, 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 bum. Maybe we start with interview questions. Maximum depth of binary tree. Given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. Okay. We want to do depth first traversal. So const stack equals that. And we essentially want to let max depth equal 0. All right, so we want to do a depth first traversal, but every time we do the depth first traversal, we also want to take a look at the length of the stack, because that's how deep we are. And as the stack gets bigger, we want to look at the stack after each loop and snapshot its length. And if its length is ever higher than max depth, we want to update max depth to the length of the stack. And that should solve the problem. While root and stack.length if root, we want to push it onto the stack. Stack dot push root. Root equals root dot left. Const max depth equals math dot max of max depth and stack dot length. Else root equals stack dot pop. Root equals root dot right. Okay. Let's see if we did this correctly. All right, we have a left-right binary tree. Root. While root, there is a root. If the root, stack dot push the root onto the stack, and then root equals root dot left, we traverse to the left. And the max depth is 1, because we're down 1. Okay, cool. And we come back. If root, there's still a root. Root, stack dot push root. Now there's 2 roots on there. Oh, this is putting us over by 1. Easier to keep it correct there. Alrighty. Root.left is null. Now root is null, but we have 2 on the stack. We come back up here, we have a stack.length. Root equals stack.pop. Yeah, I think this works. Okay. My answer, 3. Okay, so apparently this didn't work. Let's go put this one into the debugger. Oh, while root or stack.length. Duh. Okay. Let's go to the debugger. Oh, this doesn't work. This only works if the left-handed branches are the deepest. Okay, well... we can do this if we cover the other side. Yeah, oh no. I wish I could get this visualized. Oh, that only works if it's all the way down the right-hand path. Yeah, this just doesn't work. Okay. We need to try something else. Do we have to do something recursion related? I'd like to avoid recursion if possible. Just because A, it's complicated, and B, it's not actually used in real life very often. It's pretty bad programming practice. It's very memory inefficient in comparison to a loop. Well, maybe recursion's the answer here. And I might as well get some practice on recursion anyway, because okay, if we want to do this recursively, can I keep this structure? Can I traverse it with a while loop, but otherwise make use of data structures to track the depth? Each time we run the loop, we are going down a level. Unless we pop. Every time we go down a route, this is gonna solve it. That counts the nodes, but not the depth of the nodes. Okay, let's abandon this approach. Let's try a recursive approach. Const get depth equals root depth All right, so first we traverse left, then right, and then we return the maximum depth of the left and right. there's no root, return depth. Left depth equals get depth of root dot left, and depth const right depth equals get depth of root dot right, and depth depth plus plus. Depth plus plus. So much easier recursively. Holy shit. All right, hold on. Does this work? If there's no root, return depth. Okay, we get 3 in here. Get depth, root 0. Comes in, there's a root, depth becomes 1, left depth becomes root of left, and depth, so we pass in 1, and this, that becomes 2, left null, right null, bounces back up, we're at right depth. So this is 2. Left depth is 2. Right depth. Okay, I think this might work. Yes. 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 Oh my god, so much easier recursively. Holy shit. Can you do this iteratively? Answers, they're so bad. Like this in real life is horrific code because it combines too much complexity into too few lines. It's very hard for the human brain to parse this out. It's a couple of toy problems down. Let's play a game of Magic, and then let's do some more toy problems after that. Quick game of Magic to break up the toy problem. Toy problem, oh my gosh. Toy problems like drain your brain so fast. Ooh, I like this hand. I like this hand a lot. We gotta get that gold span out there soon. Turn 3 gold span? I like it. We're trending towards it. Alright. Turn 3 gold span dragon. Kalane, reclusive painter. Kalane, the reclusive painter. Yes, I've sent out a painter to do battle against a werewolf. The werewolf is a lot stronger than the painter. But the painter lets us do this. 6/6 gold span dragon, turn 3, baby! There we go. Hey, Nikki. Yeah, he quits already. What an explosive start. There we go. All right, one more game, because that one went pretty quickly. And then we'll go do some more toy problems. Ghosts, painters, and dragons. What a combo. Yes, this is a very different deck. Do I want to take this block? No, thank you. We want both of these guys to die next turn so we can get 2 treasure tokens. I am in trouble. Alright, we got the dragon out. Turn 3 gold span dragon, hopefully is good enough. What a mistake. What a mistake. Oh, concede. Concede. Oh, what a blunder. All right. We're gonna do best of three. One more game. What a mistake on my part. Oh my gosh. Get out there, Fireblade Charger. Blue, black, white. Interesting. This seems like some sort of control deck. Slow start for me. Slow start. Venture into the dungeon. Is this some sort of dungeon deck? Venture. I'll double block to kill it. Nadar, selfless paladin. All right, he's got another one. Did he miss his mana drop though? No, he did not miss his mana drop. Another showdown of the Scalds. Man, I think we're gonna lose to the Dungeon Crawler deck. Man, I don't know if I really have an answer to this deck. To this board. Sorry. struggling here. Oh, that's too bad. 2 losses, 1 win. Losing record. Too bad, too bad, too bad. All right, let's get back to some toy problems. Let's get back to work. Oh, we've already solved this one. Let's just get that submitted for credit. Validate binary search tree. Given the root of a binary tree, determine if it is a valid binary search tree. A valid BST is defined as follows. The left subtree of a node contains only nodes with keys less than the node's key. The right subtree of the node contains only nodes with keys greater than the node's key. Both the left and right subtrees are also binary search trees. Try and do this recursively. So a valid tree is made up of individual small valid trees. So this is really all you have to examine. So you take the node, you check the left node, check to see that the left node is less than it. Then you check the right node and you check that the right node is less than it. If both of those are true, then you call again recursively down into them. Otherwise, you return out. Okay. Const check tree equals root, comma, is binary, is BST. Okay. Const is left valid equals if there's no root, return is BST. const is left valid equals root dot left I'm thinking about cases of like where the left and right nodes don't exist right now. returned. Alrighty. So, if, don't know if it's an if or not. What are we saying here? Okay. Okay. If root dot left, if root dot right, let is left valid equal, I think we'll go with true, but we may need to actually set that to false. We'll see which one's more convenient in the long run. Let is right valid equal true. Oh yeah, we do want to default these to true because because if the nodes don't exist, we don't want that to penalize the tree because that doesn't really have a bearing on whether or not the tree is valid or not. So if there's a left root, then is left valid equals root.left.val is less than root.val. Is right valid equals root.right.val is greater than root.val. It's actually greater than or equal to, right? If there's no root or it's not a BST, this is a little confusing. This is kind of dirty code. Validate binary search tree. Hey, this is listed as a medium, but okay. Well, let's keep at it anyway. Wait, it works for both of these examples? That 3 shouldn't be there. Oh, this is trickier than I thought it was. Well, I successfully wrote my algorithm, but my algorithm was wrong. Oh boy, should have caught that. All right. Somehow want to be able to keep track of values that you can't be greater than or less than. What if we keep track of like min and max? want to turn in on this problem for a moment. I was heading in the right direction with the min and max. I don't want to read this too much. We'll come back to this later. Okay. Let's... What do we want to do right now? I want to keep working, but I want to take a break from toy problems, because after about an hour and a half of them, my brain definitely starts to reach its fill on toy problems. But I want to keep working, so what do I want to keep working on? Maybe I should build something. It's actually not a bad idea for getting practice and just building and launching software. Could think of a website idea to build. If I want to build something though, I want to build something that has purpose. The reason I want to build something is that it's just another way to get practice in software engineering, but less toy problem-y and more just actual software engineering, which I think is going to be important for my job and interview process as well. So let's start thinking about that. Let's start thinking about let's stand up. I haven't eaten breakfast yet either. What's a good... I could do the Amazon Alexa idea. Ooh, character generators. Those are really easy, though. Character generator could be pretty interesting. A good web app idea. I'm mostly interested in web app technology. What about a dating app for gamers? That'd be a nightmare. What's something that I would want as a streamer? What's something that I, as a streamer, would set my content apart? I wonder if I could make my own cryptocurrency and make it a reward you could get by watching me in stream. That could be interesting, creating a cryptocurrency. That could be fun. How to create your own cryptocurrency. That's mostly just a meme. We've only been live for 15 minutes. Something must have happened. Twitter bot could be interesting.
Developers, you've heard they're a great way to beef up your resume or learn a new technology or framework. Problem is, you don't know what to work on. Well, don't worry. I got you. By the way, make sure you hit the like button so this video gets recommended to more people. Subscribe to the channel, things I get asked about. And for a project, you can either have a MVP, which is a minimum viable product, something that just has the core functionality of your project, or you can build out a bunch of extra features on top of it, add an interface, just build them locally on your machine, have some Go database queries, and it takes care of all of that for you. So all you need to do is call that from your front end application. So I highly recommend that if you're looking to get something up and running fast on your back end. You could build out certain features of apps. I had an interview once where they wanted me to build out a feature from Amazon where, you know, when you click on a product and it says people who bought this also bought this. So you have to think about like how you want to model your data, how that's all going to work, which was a lot harder than you'd think. You could build out a chat service. So this is something that I had to do for my networks class in college. This gets you familiar with socket programming. I did this in C, but languages like Python and Java do have support for this. I do recommend doing it in C because Python and Java abstract away a lot of this stuff that's going on under the hood. But yeah, if you don't know what a socket is, it's basically a communication pipe that transfers data between two programs on a network or a computer. So basically you would have one process running as a server, you would have different clients connect to it, and the clients could send messages to each other that would pass through the server, and the server would route it to the whichever client it's supposed to go to. You could rewrite Linux commands, so the popular commands like pwd, print working directory, or ls, which lists the items in a directory. This is a good exercise because it gets you comfortable with systems programming. And yeah, look into system calls if you want to do this one. You could build a search engine, which is essentially web crawler. I'll let you look into that. You could build a web scraper. Web scrapers are programs that go through a website and extract data, such as the images or the links. The first video I ever did on this channel was building out a web scraper. The quality isn't that great, but I think it's still a good lesson. You could build out an elevator control system. This is great practice for object-oriented design. You could build a bug tracking app like Asana. A lot of companies use this to keep track of their bugs and the states that they're in. This is also a good one to showcase if you're looking for a job because most companies use some kind of tracking system like this. So it's a good way for them to gauge whether your app is good or not. You could build out different types of mobile applications. You could do something like a Tinder-based swiping app for dogs. Wait, does that already exist? You could design a Shake Shack menu. So I don't know if you've ever been to one, but basically you walk in, you don't talk to anyone. You just go to this iPad and you put in your order and then you just wait and they call your number. You can build out an application using a public API. You can do something like, I don't know, pull sports statistics and just like do something cool with that. Games, obviously there's a lot of opportunity there. You could recreate something like chess, battleship, blackjack, snake, or if you want to build like a full-fledged game out, I would look into Unity. You could build out a Discord bot. By the way, if you want to join my Discord server, there's a link down in the description. You could build out a packet sniffer. Basically what that is it's a application that can track or monitor all the traffic that's moving along a network. Just make sure you're not running this on any type of public network because I'm pretty sure that's illegal. You could build a Google Chrome extension, either create a new one or recreate an existing one. One that's probably on the easier side and one of the most useful is to build out a personal website. You could do a facial recognition application, making sure people don't vote twice. Obviously, you'd want to do this on something that has a camera on it. You could build out a data visualizer. This is something I saw another YouTuber doing. It was a really cool application. So how it works is you have a grid, you pick 2 points.
Ooh, an event alert system. Our reclusive painter has not done so well. I'm trying to find a project idea to work on as well. I want a project to practice my software engineering with, but I'm not quite sure what project I want to build. You want to know what? We've already started the Amazon Alexa one. Let's finish that Amazon Alexa project. Yeah, we're going to do that. We're going to finish that Amazon Alexa project. All right, we're at about 2 hours. All right, let's play a little bit of Magic the Gathering and then let's call it a stream. Actually, I'm gonna call it a stream now because I want to work on the yeah, let's just call it a stream right now. Actually not a little early. This is the longest morning stream we've done thus far. All right, I'm gonna head out and I'll be back probably this afternoon for a little bit of streaming with Dadmaster. Have a good rest of your day as well, Nikki. I'll be back this afternoon.